What makes the Nobel Prize in Physiology or Medicine a beacon of achievement in the field of medical science? This prestigious award is more than just a gold medal and a handshake. It represents the pinnacle of recognition for those who have made outstanding contributions to medicine and physiology. It's an affirmation that a scientist's years of diligent work have made a significant impact on our understanding of the human body, disease, and health. This prize doesn't merely celebrate past achievements, it also inspires future innovation, setting the bar for scientific discovery. So let's delve into the fascinating world of these laureates, their groundbreaking work, and their enduring legacies. The journey of Nobel laureates in physiology or medicine began in 1901. The first laureate was Emil Adolf von Behring, a German scientist who was awarded for his invention of serum therapy for diphtheria. He was a doctor of medicine from the University of Berlin and was 39 when he received the prize. In the following year, 1902, the laureate was Ronald Ross from the United Kingdom. A doctor of medicine from St. Bartholomew's Hospital Medical School, Ross was awarded the Nobel at the age of 45 for his discovery of the life cycle of the malaria parasite. 1903 saw the award going to Niels Ryberg Finsen of Denmark. This doctor of medicine from the University of Copenhagen was 49 when he was honored for his invention of phototherapy for the treatment of tuberculosis. In 1904, the laureate was Ivan Petrovich Pavlov, a Russian scientist. A doctor of medicine from St. Petersburg Military Medical Academy, Pavlov was 57 when he was recognized for his work on the physiology of digestion, including the discovery of conditioned reflexes. The following year, 1905, Robert Koch from Germany, a doctor of medicine from the University of Göttingen, was awarded the Nobel at the age of 60. He was recognized for his discovery of the causative agents of tuberculosis and cholera. In 1906, the laureate was Camillo Golgi of Italy. This doctor of medicine from the University of Pavia was 65 when he received the prize for his discovery of the Golgi apparatus, a cellular structure that plays a role in protein transport. The year 1907 saw Alphonse Laveran from France, a doctor of medicine from École de Médecine Navale de Brest, being honored at the age of 63. He was awarded for his discovery of the trypanosome parasite, the causative agent of African sleeping sickness. In 1908, the laureate was Paul Ehrlich from Germany, a doctor of medicine from the University of Strasbourg. Ehrlich was 53 when he was recognized for his work on immunology, including the development of the first effective treatment for syphilis. The final laureate of this decade, in 1909, was Emil Theodor Kocher from Switzerland. A doctor of medicine from the University of Bern, Kocher was 64 when he was awarded the Nobel for his contributions to surgery, particularly thyroid surgery. These pioneers set the stage for what the Nobel Prize represents today, a celebration of human ingenuity and dedication. As we move forward, the laureates from 1911 to 1950 continued to push the boundaries of medical science. This era was marked by revolutionary breakthroughs that forever changed how we understand and approach health and disease. In 1912, Alexis Carrel, a French surgeon and biologist, was awarded the prize for his pioneering work in vascular suturing and transplantology. His techniques paved the way for the future of organ transplantation. A decade later, in 1922, the duo of Frederick Banting and J.J.R. MacLeod were honored for the discovery of insulin, a breakthrough that offered hope to millions of people living with diabetes. In 1930, Karl Landsteiner, an Austrian-American immunologist and pathologist, was recognized for his identification of human blood groups, a discovery that made safe blood transfusions possible. Then, in 1945, Sir Alexander Fleming, Ernst Boris Chain, and Sir Howard Florey were jointly awarded the Nobel for their discovery of penicillin, the world's first true antibiotic. This discovery marked the beginning of the antibiotic era, saving countless lives from bacterial infections. The 1950 laureate, Edward Calvin Kendall, along with Thaddeus Reichstein and Philip Showalter Hench, received the award for their discoveries relating to the hormones of the adrenal cortex, their structure, and biological effects. Their work revolutionized the treatment of rheumatoid arthritis and other inflammatory diseases. These laureates not only advanced medical science but also left an indelible mark on humanity. Their groundbreaking work continues to influence and inspire the research and medical practices of today. Their legacy is a testament to the power of scientific curiosity, perseverance, and innovation. The second half of the 20th century saw the emergence of modern innovators in the field of medicine and physiology. Their groundbreaking work has shaped our understanding of medicine today. In this era, the Nobel Prize in Physiology or Medicine was awarded to a diverse group of scientists whose contributions spanned a broad range of disciplines. The laureates of this period include the likes of Rosalind Yalow, awarded in 1977, who made significant strides in radioimmunoassay techniques. Another laureate of note is Albert Claude, who, along with Christian de Duvet and Georges Palade, was awarded the prize in 1974 for their work in the structural and functional organization of the cell. The 1980s and 90s saw laureates who made significant contributions to the understanding of the human genome and the role of genes in health and disease. For instance, in 1989, J. Michael Bishop and Harold Varmus were awarded for their discovery of cellular origin of retroviral oncogenes, which greatly impacted cancer research. As we moved closer to the turn of the century, the laureates' work became increasingly focused on genetic and molecular processes. In 1993, Richard J. Roberts and Philip A. Sharp were recognized for their discovery of split genes, a breakthrough that redefined our understanding of how genes work. In the last year of the 20th century, Arvid Carlsson, along with Paul L. Modrich and Aziz Sankar, were awarded for their work on signal transduction in the nervous system and DNA repair, respectively. These modern innovators stand as testament to the power of scientific inquiry and the pursuit of knowledge. Their contributions have not only expanded our understanding of the human body and disease processes, but also paved the way for future breakthroughs in medicine and physiology. In the new millennium, the Nobel Prize laureates continue to redefine the frontiers of medical science. From the discovery of revolutionary techniques to the development of groundbreaking therapies, these brilliant minds have made extraordinary contributions to our understanding of human health. In the early years of the 21st century, laureates like Sidney Brenner, H. Robert Horvitz, and John E. Solston in 2002, and Richard Axel and Linda B. Buck in 2004, illuminated our understanding of genetic regulation of organ development and programmed cell death and odorant receptors in the nose, respectively. Fast forward to 2023, we encounter a remarkable duo whose work has had a profound impact on global health. Katalin Karikó and Drew Weissman, this year's laureates, have been awarded for their pivotal role in enabling the development of mRNA vaccines. A Hungarian-born biochemist, Katalin Karikó, and her American colleague, Drew Weissman, revolutionized vaccine development with their exploration of how mRNA interacts with the immune system. Their findings laid the foundation for the rapid development and deployment of effective vaccines against COVID-19, marking a significant milestone in our fight against the pandemic. Their groundbreaking work has not only offered us a lifeline in a time of global crisis, but also opened up new potential for future vaccine development. The recognition of their work underscores the Nobel Prize's commitment to honoring those who make significant contributions to humanity's well-being. It's worth noting that every laureate, from Emil Adolf von Behring in 1901 to Katalin Karikó and Drew Weissman in 2023, has left an indelible mark on the field of medicine. Each of them, in their unique way, has expanded our understanding of life's complex mechanisms, improved our ability to diagnose and treat diseases, and enhance the quality of life for people around the globe. These recent laureates exemplify the relentless pursuit of knowledge and the power of science to solve humanity's most pressing challenges. From Emil Adolf von Behring in 1901 to Katalin Karikó and Drew Weissman in 2023, the Nobel Prize in Physiology or Medicine has honored those who have significantly advanced the field of medical science. This prestigious award has celebrated breakthroughs and innovations, from the discovery of serum therapy for diphtheria to the development of mRNA vaccines for COVID-19. The laureates we've taken a walk through in this video represent a century of medical advancements. Their work has not only expanded our understanding of human physiology and disease processes, but also laid the foundation for countless treatments and cures, saving and improving millions of lives along the way. The Nobel Prize in Physiology or Medicine serves as a beacon, shedding light on the critical importance of scientific research in the quest to conquer diseases that afflict humanity. It underlines the value of curiosity, persistence, and dedication to the cause of alleviating human suffering. The legacy of the Nobel Prize in Physiology or Medicine is not just about the past. It's a living legacy that inspires current and future generations of scientists, doctors, and researchers. The work of these laureates underscores the power of scientific discovery to change the world, one breakthrough at a time. As we celebrate these laureates, we also look forward to the future discoveries that will continue to push the boundaries of our understanding and improve the human condition. For in the words of Alfred Nobel, contentment is the only real wealth.